Hello to our loyal four-eyed audience. Welcome back to Through the Looking Glass, a weekly student-run podcast where we look at different viewpoints each week surrounding eyesight.
So how was everyone's weekend?
Great, I saw a new movie.
That's sick.
Yeah, I went to the movie too, but I forgot my glasses, so it was blurry the entire time.
Oh, I hate when that happens. I always forget my glasses when I need them the most.
Jeez, that sucks. Why do so many people have to wear glasses nowadays?
Well, I have no idea, but I can tell you that I just got diagnosed with myopia.
Myopia? Sounds serious.
So there's an increasing proportion of the global population who now require glasses for proper vision. One of the main reasons for this is a common refractive vision disorder, myopia or nearsightedness.
In my experience, myopia makes it very difficult or even impossible to focus on images in the distance. I mean, I wear glasses to help with it, but it's definitely a hassle in my daily life.
Well, the reason why you can't focus on images in the distance is because of the abnormal elongation of the eyeball. This causes refractive images formed by the cornea and the lens to fall in front of the photoreceptors of the retina.
We're all born with hyperopic eyeballs, and that means they're shorter than their final size and elongate based on visual inputs. If your eyes elongate past the normal length, you become myopic.
Okay, but why did I develop it so late? I was able to see just fine as a kid.
Well, your eyes probably didn't elongate past the normal length until later on. This happens at different rates for people who are susceptible to myopia for many reasons. First, we'll need to discuss exactly why people have myopia.
There has to be an evolutionary explanation, right?
Well, the underlying biological cause of myopia is unknown. However, it's hypothesized that there are both genetic and environmental causes.
Fact: myopia is a century-old problem. Although we found ways to combat it, like wearing glasses, contact lenses, or corneal surgery, we still have a long ways to go in uncovering a successful cure.
Myopia impacts a variety of people, varying among ethnicity, geographic locations, and socioeconomic status. If left untreated, moderate myopia can become one of the leading causes of visual impairment.
The greater degree of myopia, the greater risk of complications that may include muscular degeneration, retinal detachment, cataracts, and glaucoma.
So there's varying severities of myopia?
There's two clinical designations for myopia: pathological degenerative and spontaneous onset, sometimes also called school-age myopia.
Yeah, pathological myopia is the more severe of the two. It's when you have rapid, extreme axial elongation of the globe, leading to a high refractive error. It puts a lot of stress on your ocular structures and can cause degenerative changes in the eye and irreversible vision loss.
Oh God, do you think that's the type I have?
No, pathological myopia is pretty rare. It affects only about 0.9 to 3.1% of the population.
Whew, didn't see that one coming.
Wow, what a comedian! The more common form of myopia is school-age myopia. It basically progresses slowly and stabilizes around 20 years old.
Okay, well I guess that makes sense why I only noticed it during my teens then. But I always thought that I might need glasses because my mom's whole side wears them.
Yeah, that's definitely a contributing factor. There's significant heritability for many genetic factors that influence you developing myopia. So let's move on to the genetics of this condition. There have been many studies looking at family histories, twin studies,
Pedigree analyses, and population studies.
Yeah, they all show the involvement of different genes and loci associated with myopia.
So why don't we look at the results from these studies that provide strong support for the genetic basis of myopia?
Yeah, well, like I was saying, my mom's entire side of the family has glasses, so I'm assuming this puts me at a higher risk for myopia then?
Well, I found an interesting study on this topic by J.M. Ip and his team, where he studied over 2,500 Australian children and looked at the risk rate of developing myopia based on if your parents were also myopic. Basically, children with both parents being myopic had a 43.6% chance of developing myopia compared to only a 7.6% chance with no myopic parents.
So to put that in English terms, you're saying that the study is showing myopia is a strongly heritable trait and can be passed down from your parents.
Yeah, but then there's not an 100% chance that you'll develop myopia if both your parents have it. Both my parents have glasses and I don't need them yet. Knock on wood.
Me too. I feel like I'm gonna end up having glasses when I'm older.
Well, isn't that nice? Join the club.
Sorry. Also, a strong genetic correlation of refractive power was found by J.I. Carlson through twin studies.
Refractive power?
Yeah, that's just your ability to see objects from far distances. So people with myopia like me have lower refractive power than your average Joe.
That's us.
Exactly. So Carlson and his team found that 95% of identical twins have a similar refractive power, but only 29% of fraternal twins do. Essentially, you're likely to have similar vision abilities to people that you're more genetically related to, like your identical twin.
Oh, which strongly supports the heritability of myopia.
Yeah, and pedigree analyses also support the genetic basis of myopia. A bunch of lucky researchers did the work for us, and they found that 18 gene loci are associated with high and common myopia.
Right, you told me about this. It's listed in one of my favorite online sources, the Online Mendelian Inheritance in Man database.
Okay, alrighty then. To get even more scientific, these gene loci can either be genetically linked through autosomal dominant, autosomal recessive, and X-linked recessive inheritance. So this is all the fun biology that you learned back in grade 12. And there are many types of heritable genes that can influence your probability of developing myopia.
So those studies are all looking at families, but there's also been larger ones that show correlations with various genetic markers and myopia. Julia, I think you were talking about population studies?
Yeah, a study by Kiefer and Verhoeven showed that 12 single nucleotide polymorphisms are statistically significant and associated with myopia. This suggests that the involvement of multiple gene effects, which is predicted in a complex condition.
How are they finding out how all these genes associate anyways? Like, do you guys know the forms of technology they're using?
Well, those particular studies were found by pedigree analysis and familial aggregations, but nowadays a much more common way is through genome-wide scans or GWAS and genetic mapping. Actually, I just read a meta-analysis by Li and Zhang that talked about utilizing these new technologies to map complex traits and successfully identified 6 susceptibility loci for myopia.
Yeah, they were also reviewing studies that screened candidate genes within those susceptibility loci. This was according to their related function, and they found that the expression of these candidate genes was present in various ocular structures. That includes your cornea, your lens, iris, basically all throughout the eye.
Okay, so myopia can be heritable and has that genetic proof, but how did this even evolve? When did it evolve? Why did it evolve?
Lots of questions there. Well, I mean, clearly our ancestors didn't wear glasses.
Funny you mentioned that.
Can you see where we're going now?
So, do you guys think myopia developed recently, or did our ancestors have it too?
Well, a professor of ophthalmology at the University of California, Dr. Ivan Schwab, stated that as long as primates have been around, there's probably been myopia.
So if you think about it, the ancient world was a dangerous place where people who suffered from vision problems likely had a lower life expectancy due to vicious predators. Someone with myopia wouldn't have been able to identify a threat until it was close enough to even see.
Yeah, obviously if the threat was a nearby saber-toothed tiger, you wouldn't have time to react.
And they wouldn't be able to see their prey either. You would likely have gone hungry and died.
So by that logic, wouldn't our nearsighted ancestors have been selected against? And wouldn't the genes for myopia have died off by now?
Yeah, it would have definitely lowered their fitness, but for some reason some of these genes stuck around. Maybe they were present in the mothers that stayed protected while the fathers went out and did all the hunting. We don't really have evidence for the exact reason why they stayed in the gene pool, but they certainly did.
I mean, that's a good prediction. We just talked about there being heritable X-linked genes for developing myopia, so perhaps their evolutionary origin comes from those moms who stayed out of harm's way.
Yeah, and as time passed and societal roles developed, myopic individuals were given other tasks to do besides hunting. You may have had someone making clothing, telling stories, or acting as oral historians. Those all didn't require a long range of vision.
Okay, well, correct me if I'm wrong, but I feel like vision issues weren't even prioritized back then. There were more important things to focus on in that time period.
Exactly, you didn't need good eyesight to hear a song, plow a field, practice trade. Dr. Schwab even said that those who were afflicted with poor eyesight probably believed they'd just fallen out of favor with the gods. They just simply continued to live their lives as best as they could.
And what if nearsighted artisans had an advantage when it came to their craft? Artists and coin engravers didn't require long-range vision because most of their work took place only a few feet away from their eyes.
Yeah, that's true. Well, we clearly care about vision issues today, so when did we really start addressing all these vision problems?
Well, according to a museum curator at the College of Optometrists, Neil Hanley, the earliest known eyeglasses were only invented in the 13th century in northern Italy, but the glasses for nearsightedness only arose in the 15th century.
Yeah, and from that point onwards, the cost associated with myopia was much lower. You could just throw on a pair of glasses and keep spreading those bad genes to your kids, and their kids, and their kids, and their kids.
Nowadays, you don't have to worry about woolly mammoths chasing you down the street. And even if you did, you just chuck on a pair of glasses. As technological advances continue, we're interfering with selection against myopic people.
Joining us now via Skype, we have scientist Francis Young, who conducted a study with his colleagues regarding environmental impacts on myopia. Hi, Francis.
Hello, I'm excited to be joining you today.
Glad to have you. So what can you tell us about your work?
So in 1969, my colleagues and I studied Inuit individuals on the northern tip of Alaska who are undergoing many lifestyle changes. And of these 131 individuals that were studied, we found that only 2 of them had myopic eyes. Now the interesting fact here, girls, is that more than half of their children and grandchildren had the condition.
Could that just be attributed to a hereditary factor?
Well, not quite. This rapid change occurred far too quickly for genetics to be the only explanation. So this is when we realized that there must be an environmental effect causing these generational differences. And in this case, that generational difference was bookwork.
Bookwork?
Yes, quite similar to how you guys have your eyes glued to computer screens today, engaging in reading or studying for that matter. Really, any near-plane activity encourages the eye to become myopic to meet the environmental need.
So clearly environmental needs are changing. So what you're really explaining through this is a theory of evolutionary mismatch.
And for those of you who don't know, evolutionary mismatch is a fancy term used in evolutionary biology that refers to evolved traits that were once advantageous but became maladaptive due to changes in the environment.
Exactly. So in this case, selection against the ancestral populations with myopia was high due to the large costs associated with myopia. With the changing environment and our current resources, the strength of selection against myopia has become more relaxed. It's no longer considered a maladaptive trait, but rather more neutral.
The recent increase in the use of electronic devices and close work now requires our eyes to focus on near objects, right? So it's basically a trade-off for modern work environments.
That makes sense. Another environmental-based hypothesis suggests that myopia is related to increasing time spent indoors.
Oh yes, the indoor work hypothesis.
A study published in 2013 by French and his colleagues suggested that children who spend more time outdoors are actually less likely to become myopic.
Yes, sunlight stimulates the production of vitamin D, as well as the release of dopamine directly into the eye.
And they found that this increased dopamine release appears to inhibit increased axial elongation, which is the structural basis of myopia.
So in simple terms, dopamine stops the excessive growth of the eyeball and prevents myopia. It's basically another mismatch between the outdoor environment in which we evolved and modern indoor activities such as reading and playing video games that we now practice.
Thanks so much for joining us, Francis. You really shed some light
And vitamin D!
on that topic.
So I've recently discovered some remarkable data that makes this discussion even more interesting. Myopia actually has different incidence rates depending on different ethnicities.
Oh really? Are the differences large?
Oh yeah. Geographic variations in the prevalence of myopia are present in both adults and children. The highest levels of myopia appear to be in East Asian ethnicities, with over 90% of East Asians living in Singapore and 72% of East Asians living in China, aged 18 years, exhibiting myopia.
Jeez, over 90%?
Yeah.
Wow, that's huge.
I know, and get this, the lowest prevalence is in the late adolescence of Black children in Africa, with only about 5.5% diagnosed with myopia.
That's crazy. So obviously there's something going on if there are these significant differences between ethnic groups.
Exactly. So this group of researchers from the University of London, led by Dr. Alicia Rudnicka, recently completed a meta-analysis looking at global variations and time trends in the prevalence of childhood myopia. They basically established that the variations in these incidence rates suggest that environmental factors are important determinants of myopia.
Well, if there's varying incident rates depending on different ethnicities, doesn't that just point to genetic factors?
I mean, we've already discussed how both genes and the environment play a role, but the reason why the researchers notice patterns emerging with environmental factors specifically is due to 2 reasons. 1, the prevalence of myopia is increasing within each ethnic group, and 2, there's a universally high risk of myopia within urban settings.
Okay, wait. So you're saying there's been an increasing prevalence of myopia in all ethnic groups?
Yeah, so genetic factors may be contributing to the ethnic groups having different levels of myopia, but environmental factors are likely contributing to the universal increase and prevalence.
Okay, so how much higher are the risks for those living in these urban settings?
Well, in 2016, Dr. Rudnicka and colleagues found that living in an urban rather than rural environment is associated with almost a tripling in the risk of myopia, and this pattern is seen among all ethnic groups.
So for those who migrate to urban or rural areas, do they adopt either an increased or decreased risk depending on the new environment?
Yeah, so the research found that population groups that migrate from rural to urban settings tend to adopt myopia rates of the host population.
So it appears that there are significant environmental factors at play. What do you guys think they could be?
I mean, potential explanations that the researchers came up with included the fact that urbanized settings include more congested environments and overall have a greater emphasis on education and therefore near vision activities.
Right, and several studies have shown a link between increased near vision activities and myopia. That's what Francis was talking earlier about.
Yeah, years of education can also be linked too, and introductions to formal education at younger ages tend to occur more frequently in some East Asian countries.
And that's exactly what the researchers suggested. The prevalence of myopia is low in African populations where literacy rates are also low, and formal education doesn't really start for most children until the ages of 6 to 8. Basically, it's possible that the younger age of initial exposure to formal education is linked to levels of myopia throughout childhood.
Neat.
And relating back to what we spoke about earlier, children are more likely to spend time outside, more so in those rural areas as opposed to urbanized areas.
Okay, but we also have to remember genetic factors. For example, ethnic differences in myopia prevalence still exist, even within the same living environments. So it's not just environmental factors at play here.
I mean, you're definitely right. The paper's main conclusion was that it appears that populations that have experienced rapid economic transitions, like East and South Asian populations, have undergone the most rapid myopic transmissions. It just goes to show how influential both genes and the environment can be on the expression of traits.
So that was a lot of information.
Yeah, to sum it all up, myopia can be onset from both genetic and environmental factors. They both tend to reinforce each other.
And many heritable genetic factors influence just how vulnerable you are to developing myopia. But because you are not typically born with the condition, the environment you grow up in plays a huge role in whether or not you will be nearsighted later on.
Exactly, and the way that our environment has changed over time has created that environmental mismatch we talked about earlier.
In modern environments, there's much weaker selection against myopia because we have the resources to deal with the issue.
So I guess my nearsightedness could have been from inheriting my mom's bad eyesight genes, or I guess just me staring at my laptop for too long watching Netflix.
Moral of the story? Just don't forget your glasses the next time you go see a movie.
Thanks for tuning in to this week's segment of Through the Looking Glass. This is Sydney,
Julia.
Crystal?
And Malika.
signing off.
See you next time!